Okay, so today we're doing some integration questions again. So this one is rather straightforward, I think. So not really. It's less straightforward than the one I did yesterday, but this one's also quite easy. So in part A, if we're proving this, I believe, not even I believe, this is just doing integration by parts. So obviously is equal to this, and then we have cosine 2a is 2 cosine squared a minus 1, which means cosine squared a is equal to 1 over 2 plus 1 over 2 cosine 2a. So we have 1 over 2 cosine 2x plus, whoops, excuse me there, dx plus 1 over 2 cosine squared 2x dx. And then here, obviously, we could have 1 over 4 sine 2x plus, here we do by parts, x, so this should be a 1 over 4. That's a 1 over 4, that's also a 4. So we have plus 1 over 2 sine 2x cosine 2x minus 1 over 4 sine 2x d cosine 2x. And then here we could use the same identity again. So this is 1 over 4 sine of 2x, 1 minus, whoops, it should be 2 cosine squared of x minus 1, minus 1 over 2 of sine squared 2x dx. That should be a plus. Here, this thing is just sine 2x cosine squared x over 2 plus 1 over 2 sine squared 2x dx. And then that's it. That's part A. Part B wants this, which is 0 to pi of 0 to pi of the first expression plus 1 over 2 0 to pi sine squared 2x dx. Firstly, this is 0. I think anyone with a brain will understand that. And second, cosine 2a is equal to 1 minus sine squared 2 sine squared a. So we have sine squared a is equal to 1 over 2 plus 1 over 2 cosine of 2a. So we have 0 to pi of 1 over 2 dx. Whoops, which is just 1 over 4 dx. Plus 1 over 4 from 0 to pi of, I believe, cosine 4x. Yes, cosine 4x dx. This is x over 4 of 0 to pi plus, wait, is that 1 over 16? So cosine 4x, so sine 4x, okay, so 1 over 16 sine 4x from 0 to pi. The second part is 0, so we have pi over 4. And that's it for part B. Part C, well, part C just gave us the biggest hint in the world, which is to use substitution. So part C, first of all, is from 0 to pi of x cosine squared x. Wait, is that xgx? Yep, exactly. xgx of dx, whoops, excuse me there, which is just 0 to pi of x cosine squared x cosine 2x dx. Frankly speaking, let's set u equals pi minus x. This one's quite straightforward because we have 0, we have pi, and then we have trig functions. So we could use pi minus x as a substitution, and then we could get some, dummy variable type of things. So we have du is negative dx, which and obviously x equals 0 means u equals pi. X equals pi implies u equals 0. So we have 0 to pi of pi minus u, cosine squared pi minus u, cosine 2 pi minus 2u du. And this one should be a negative, but it's over there because we flipped the integral. So we have 0 to pi of pi minus u. Cosine squared pi minus u is just negative cosine u squared. So we have cosine squared u. And then cosine 2 pi minus 2u is just cosine 2u du. And anyone in the world with a brain would know this is just a dummy variable thing. So we have this is equal to that, which means we have two of these integrals is equal to 0 to pi of cosine squared x, cosine 2x dx, which is just pi times the integral in b. So we have 0 to pi of x gx dx is equal to pi over 2 of the integral in b, which is pi over 4, which is just pi squared over 8. And that's it for part C. In part D, we want from negative pi, I'm just going to check the question again, from negative pi to 2 pi of x gx dx. So this is a trig function, but so we could do the same thing initially. We could have from negative pi to 2 pi of x cosine squared x cosine 2x dx. We could use literally the same substitution. You could think it as of like 3 sections of the same thing, but I really want to make this extremely clear because from negative pi to 0, and then from 0 to pi, and then from pi to 2 pi is the same thing. But I don't really know how to explain how because it's all from intuition. So instead, I'm going to explain this in terms of substitution. So we could do the same thing. This is du and negative dx. And then we have the same stuff. So we have negative pi to 2 pi of pi minus, oops, excuse me there. Pi minus u, let's move that to the side for a bit. Cosine squared pi minus u and cosine 2 pi minus 2u du, which means we have negative pi to 2 pi of pi minus x cosine squared x cosine 2x dx, which means using part B, we know this is from okay, excuse me there. Which means again we have two of these things is equal to pi times this thing. So this is just pi times x over 4 from negative pi to 2 pi plus 1 over 16 sine 4. Is that 4x? Yep. Sine 4x from 0 to pi. Oops, excuse me there. Negative pi to 2 pi. And this is 0. And this one is pi over 2. 2 pi over 4 plus pi over 4, which is 3 pi over 4. So that's 3 pi squared over 4, which means the original integral we're supposed to do is 3 pi squared over 8, which is, frankly speaking, just 3 times the value in C. But yeah, it's really hard to explain intuition, so I'm not going to do that. Hopefully this method is clearer.